Well, good morning, everyone. As I was introduced, I'm Wes Patrick. I'm with NOAA Fisheries, and my two co-authors, Jason Cope and Jim Thorson, are also with NOAA Fisheries out of our Seattle office. And I've changed my title a little bit. It's assessing the quality of life history information in FishBase. And just to start off a little bit, I'm sure all of you all know how important life history information is in fisheries management. We use it in a lot of different contexts. For example, we might use it in our catch control rules to figure out how big of a precautionary buffer we want to put in our target reference points. We of course use it in our stock assessments and life history theory and modeling, but what I'm going to try to focus on today is focus at this workshop, ecological risk assessments. Also, as you all are probably aware, since we're working on ecological risk assessments, a very common protocol when going through the process of scoring different species is when you run into a data poor species, you often head over to FishBase, because FishBase, I think, is pretty awesome. You got 32,000 species there to draw information from. And essentially, whenever we go through this process, though, FishBase is often scored in our data quality scoring matrix. So whenever you're doing risk assessments, you might identify what is a data-rich data point you have versus something that's based off expert opinion. And oftentimes, whenever you cite information comes from FishBase, it comes down on this lower side of data quality issues. And I had this experience a couple years ago when I was working in the US on a productivity susceptibility analysis. And our work group was trying to figure out how should we define our scoring bins for like low, moderate, and high-risk species. And we had a pretty small data set with the available life history information we had. And so half of our group only wanted to use the data that they were very confident in. And the other half were willing to try to beef up our sample size by going to FishBase to include some of the information there. And so it wasn't really heated, but you could tell that there was a lot of uncomfortable people in the work group on what kind of data sets they wanted to use. And so some of this data quality issues that people were bringing up was that you have things like population-specific differences. So you might, as you know, in FishBase, you'll have information that is about one population or another. And here is bluefin tuna maximum length. If you were looking at the Gulf of Mexico, you'd see that their maximum length is 200 centimeters. Whereas in the Mediterranean, it's only 140 centimeters. And so some of our scientists were getting worried whenever you just say FishBase plainly, what information are you using there? Also, even within the same population, when you go into FishBase, I'm using here Pacific Ocean perch. If you're to go in and look at maximum age, you're going to see a lot of variability from the field surveys that's been done. And so even though there's been 5 or so field research surveys reported in FishBase, the maximum age for this species is reported as ranging from 16 to 100 years. However, my co-authors and I think that probably some of the stigmatism that comes along with FishBase really comes down to what is the data that you're using within FishBase. Is it the entered data that is from these field observations or from published reports where the authors submit their information to FishBase? It goes through some kind of quality control work by the staff, and then gets put up on these summary pages. Or is it the generated data that is derived from empirically derived estimates? And that confusion can sometimes lead your risk assessments astray when you're trying to develop your methodology. So just to make sure everybody's on the same page about what I mean between generated and entered data, just want to run through how you get this information from FishBase. So up here, I picked out Atlantic cod, and you have your summary page here. And of course, up at the top, you're going to have some summary information that's based off of entered data from observations. They'll have references that you can go to and figure out where this information came from. And if you were to scroll further down, just like Rudy was showing earlier, you'll come to this subheading that says more information. There's going to be a long list of life history parameters or information there. And so for this example, I use maturity, and you're going to get a web page that looks something like this. It'll show you the breakdown for a couple of different variables related to maturity. Here you can see that there's three reported estimates for age and maturity, the sexes of the fish, the country where they're located, and their localities. However, if you're trying to access the generated data, the way that you go about doing that is if you were on the summary page again, in that same section, you'd have to go down to the bottom right-hand side and pick up the life history tool. Or if you're on the home page of FishBase, there's a couple of different ways that you can access it, but what you're looking for example, under information by family on the home page, there's a link over to the far right that's called Species Ecology Matrix. Either one of those two links will take you to a web page that looks like this. And this is what you get for your generated data. And this is your life history tool web page. It's not going to tell you anything about the observations. It's going to give you some default values based on whatever interdata they might know about the species. And you can go in there and you can provide some different confidence intervals on the estimates. You can type in the correct maximum length if you like and recalculate, and it's going to repopulate all these different estimates for you. And the way that it goes about doing this derived estimate of these different life history parameters is sort of a logical process where if they have information, it usually starts with Lmax, goes down, and if they have the information, they'll use length at maturity. Otherwise, they'll use length at infinity, and back and forth. So what we were trying to do in this study was really just focus on this generated versus entered values and try to figure out what is the accuracy and precision of both of these values. And to do that, we needed to have some kind of reference point. And what we did was we went around to our stock assessment scientists in the US and asked them for their personal data sets. And so I'm sure many of you all here are stock assessment scientists, and you probably have your own personal database that you have, because every couple of years or so you have to rerun the same stock assessment for the species that you're an expert in. And so what we were considering their expert databases to be is not so much the perfect knowledge of what that life history parameter should be, but more so that the experts had a value that was randomly distributed around the true but unknown value. And I'll point out a caveat here. My co-authors, Jim and Jason, are the modelers in the group. And so if you have any questions about the models that we're using, I'll have to put those off. But so once we had this expert database that we had, we then used a Bayesian errors and variable model to estimate these biases. And we used that and looked at 7 different parameters that we had information on. Just to go over them really quickly, we had maximum length, length infinity, bond burden length, growth coefficient, length of maturity, age of maturity, maximum age, and natural mortality rate. And we were able to get information on 156 different species from the US. 2/3 of those were bony fish, and then the other 47 species were sharks and rays. And here's some of the output from the modeling exercises that we did. So these are the posterior distributions of bias. And I'm guessing you guys can't see that too well. Let's see if I hit the right button for the pointer. Yeah. So up here, starting at the top, this is Lmax, Lfinity, K, length at maturity, age at maturity, maximum age, and natural mortality rate. And what you're trying to look at here is, compared to our reference expert database, if you had a perfect match, then you expect this distribution curve to be along this vertical axis here that's aligned up here with 1. And so on the left-hand side, we got our teleost, and on the right-hand side, we got our chondrithes species. And the entered values are the black lines, and the generated values are your dotted lines. And one of the first things you're going to probably see up here is that, Wes, you don't have any dotted lines for your maximum length or for K. And that's because our the errors in model needed to have confidence intervals for the life history information for the generated values, and that wasn't supplied in the life history tool, so we didn't have any plots for Lmax or K. Some general observations you'll see here is that the entered values are always more accurate compared to the generated values, and that the sharks and ray species that we had information on is usually more accurate than the bony fish. And of these parameters that we're looking at, L infinity seems to be the most accurate in both categories, whereas natural mortality down here at the bottom has the most variability. And also, we couldn't find any consistent pattern in biases. So sometimes the entered values and generated values are on the same side, sometimes they're on the opposite, and vice versa. We also looked at precision, and so this is a slightly different way of interpreting the data here, which is you're looking at how closely can our standard deviations get to 0 here. So here's our standard deviations, and you see most of them range between about 0.1 and 0.6 or 7. And we also have one extra layer of information here. So when I showed you that last graph, I was showing you entered values for a local population. And what I mean by a local population is, if we were looking at California current Pacific Ocean perch, well, the data that we were comparing to was in FishBase information along the California current, or USA, is I think is what it's normally labeled as. But there's probably going to be information in there for British Columbia, Alaska, or maybe Japan or something like that. And what we're calling those other sorts of information is non-local entered values. And so that's what the dashed lines are here. So this is the non-local precision, and this is the local entered value precision. And then the small dotted line here is still our generated values. And what you'll pick up from here is that our most precise estimates are usually our length-based measurements. So L max and L infinity and L maturity seem to be the most precise, whereas natural mortality and K seem to be the least precise. And you also notice that most of the H-based ones are also out here around 0.3 or 0.4. And normally, you'll see that the non-local entered values are actually more precise than the generated values. So for some summary information, FishBase does give us some relatively accurate and precise information, and that order of accuracy depends on the type of information you're using. And some of these largest biases that we've seen is in natural mortality, K, and those age-based parameters. But we're also hoping that because we've shown what these distributions are and their biases and precisions, that maybe folks can start adjusting for those biases whenever they're using them in their analysis. And I wanted to end with an equation. I feel like if you're at a science meeting, you've got to give a presentation with an equation. And this is about as quantitative as I get. So entered data equals better data for everyone. And I just wanted to kind of put in a plug-in for FishBase, in that you'll be really surprised if you go in the FishBase and look at your species of interest. I was doing this, trying to put together a presentation, and I went to school and I did research on striped bass on the East Coast. And I was expecting to find all kinds of information that I could use to put up on this PowerPoint. But actually, when I got in there looking for an entered value, much of the information wasn't there, even though I know it exists. And I think it's just a lack of people knowing that that information is missing, or that they don't have the time. Everybody's very busy. But I think if we can all make a good effort to go back to the data banks that we keep up and make sure we provide it to FishBase and get those entered values in there, you're not only going to be helping yourself, you're going to be helping your colleagues. And also, if we have better entered data, we might even get better generated values too, because we're going to get better correlations that we can use. And so I would even take it as far, we just published a paper in Fisheries where we're challenging American Fisheries Society to start requiring that all authors submit their information to FishBase if you're providing any life history information. It kind of follows along the same thing that population geneticists do in most of the genetic journals that have to provide accession numbers for their gene bank and DNA sequences and things like that. And so with that, are there any questions?